In lesson 4, we focus on, once proving triangles congruent, applying the definition of congruent triangles to show that other parts of the triangles are congruent to each other. And so we're going to use the definition of congruent triangles to say, hey, if I used, side, side, side to show that these triangles are congruent, then I can use the definition of congruent triangles to say that the three pairs of corresponding angles are going to be congruent. And so the goal here is to really fulfill what we did in lessons 2 and 3, and then carry that on one step further to apply the definition of congruent triangles. One way to articulate that definition is this little shortcut, or this little acronym CPCTC, which stands for corresponding parts of congruent triangles are congruent. Essentially, it's just the definition of congruent triangles. It's just that for years and years, geometry teachers in geometry classes across the country have been saying CPCTC instead of definition of congruent triangles. It's basically the same idea. But we are going to prove triangles congruent, and then we're going to use the definition of congruent triangles, or CPCTC, to prove that the other parts of the triangles are congruent to each other. So again, we have our 4 shortcuts that we are going to continue to use. We've got side, 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 as I mentioned moments ago, side, angle, side, angle, and then angle, angle, side. And the reason why we start our conversation with these shortcuts is because these represent 3 of the 6 pairs of corresponding parts that are used to prove the triangle's congruent, which means that if we use 3 pairs of sides or 2 sides and an included pair of angles, then what we end up with are the remaining 3 pairs of corresponding parts that are indeed congruent to each other. So we're going to understand that if we've used side, side, side to prove the triangle's congruent, that we now have 3 pairs of angles that are congruent. If we used 2 pairs of corresponding sides congruent in the included angles, then that means that we have 2 other pairs of angles and another pair of sides that are congruent. If we use 2 pairs of angles and a pair of sides, then that means that we have now an additional 2 pairs of sides that we know are congruent using CPCTC, or using the definition of congruent triangles, and an additional pair of angles. Now, that additional pair of angles, we could obviously use the third angles theorem, or we could use the definition of congruent triangles at that point. But this was just designed to get you thinking about how these parts and pieces are related to one another. So again, just a reminder, CPCTC is a fancy acronym that just refers to this notion that corresponding parts of congruent triangles are congruent. Once we know the triangles are congruent, then we can make those statements about the other parts being congruent, just like we did in lesson 1. So if you go back to our lesson 1 notes, we said, hey, these triangles are congruent. And so we said, okay, well then these angles correspond to each other and they're congruent, or these sides correspond to each other and therefore they're congruent. And so we're going to use that here in our 4th lesson. This is just a long treatise saying it's the same thing as the definition of congruent triangles. You don't need to write all that down, as long as you understand that CPCTC and the definition of congruent triangles are the same thing, and you can use them interchangeably. So here is a situation where we are given some information. We've got this picture created, which lets us recognize not only what they tell us, but also we've got a pair of vertical angles at the center. And our job is to think about why these triangles are congruent. So breaking this down, we've got segment HJ is congruent to segment ML. We know that the angle at J and the angle at L are congruent to each other. And then finally, as I mentioned moments ago, we have these vertical angles around point K that are also congruent to each other. So these 2 triangles are congruent by the angle, side shortcut. Pair of angles, pair of sides. Angle, angle, side shortcut. All right? So because these angles are congruent using the vertical angles theorem, along with the other given information, I know that these triangles are congruent using angle, angle, side. So that then leads us to this follow-up question. All right? I didn't write this out as a 2-column proof, just kind of spitballing, making sure that we can do that 4-2, 4-3 work there and say, oh, those triangles are congruent by angle, angle, side. But the point of using CPCTC, or the definition of congruent triangles, is to say, well, once we know that the triangles are congruent, triangle, what are the letters here? JKH, congruent to triangle LKM, what other parts do we know are congruent? Basically, anything on here that is not yet marked, we know is going to be congruent, all right? So, for example, the angles at H and M are going to be congruent. The segments HK and MK are going to be congruent. The segments JK and LK are going to be congruent by applying the definition of congruent triangles, by applying CPCTC. So we've got JK and LK, we've got KH and KM, and we've got the angle at H and the angle at M. All right? So once we've shown the triangles are congruent using angle, angle, side, I know that there's going to be 2 more pairs of sides and 1 more pair of angles, 2 more pairs of sides and 1 more pair of angles. I can make that prediction early on, and then I can see it come to fruition as we work through such exercises. All right? Take a look at this situation. Using our shortcuts, and once we've proven the triangle is congruent, we have one additional statement to make. Prove that angle A is congruent to angle C. So we have this information, we have this situation where we are told that segment BD is perpendicular to segment AC. We are also told that segment AD is congruent to segment CD. And then we can use our reflexive POC to state that BD is congruent to itself. All right? So this notion right here that these segments are perpendicular, that means that these angles are right angles by the definition of perpendicular. And therefore these angles are congruent because all right angles are congruent. Therefore we have a pair of sides, pair of angles, pair of reflexive sides to say that these triangles are congruent. Once I've done that work, once I've proven that these 2 triangles are congruent, then I get to do this work where I say that angle A is congruent to angle C by the definition of congruent triangles or by using CPCTC. Same exact reason. It's the same thing, just different ways of saying it. So let me write out that proof so again you can see modeled how to do this proof to show that these 2 triangles are congruent, but then how to write that extra step that angle A is congruent to angle C by CPCTC. All right, so statement number 1, I'm going to go ahead and say that AD is congruent to CD. That information, again, is given. Next, I'm going to say that segment BD, as I stated earlier, is going to be perpendicular to segment AC. That also was given in the picture. That's what this little mark meant. All right? But now we know that that means that the angles that are formed at point D are both going to be right angles. That's the definition of perpendicular. So we will say angle ADB and angle CDB are right angles. That's the definition of perpendicular. Because those angles are right angles, we know that those angles are congruent. Because all right angles are congruent. Theorem 2-4, if we recall that. And then we have the reflexive side. Side BD congruent to itself. Again, by our reflexive POC. All right, so this gives me a pair of sides, a pair of angles, a pair of sides. So these 2 triangles are congruent now by side, angle, side. So I'm going to say triangle ADB, triangle ADB is congruent to triangle CDB by side, angle, side. So this is work that I would have expected us to be able to do back in lesson 2 and 3 to show that these triangles are congruent. Now remember, these 3 statements make this proof a little bit longer. This symbol right here means that these segments are perpendicular, which means that these angles are right angles, which means that those angles are congruent. So that's 3 statements, just like we did back in Unit 3, Lessons 1 and 2. All right, so that gives us our final statement. Now that we know that these triangles are congruent, I can use the definition of congruent triangles, or CPCTC, to show that the angle at A is congruent to the angle at C. If these triangles are congruent, then all of their corresponding parts are congruent. That means that these angles are congruent, these angles are congruent, these sides are congruent, but it asked just for this piece of information. So for my very last statement, I'm going to say angle A is congruent to angle C. And the reason is CPCTC. Or if you want to, you can write definition of congruent triangles, which we talked about back in lesson 1. Pause the video if you need to make sure that you can write all that down. Moving on to the next example. Same idea. Here we're going to do the same thing. We're going to use a secret shortcut, one of these 4, to prove that these triangles are congruent. And then our last statement will be that these segments are congruent using CPCTC, or the definition of congruent triangles. So we should note that we are given this information, given that information. We're going to have one additional step here to say that these angles are congruent by the vertical angles theorem. And therefore these triangles are congruent using angle, side, angle. 2 pairs of angles and the side that's included between those pairs. Once these triangles are congruent, triangle YAZ and BAC, then we can say that segment ZA and segment AC are congruent by CPCTC. All right? So again, talking through the proof, thinking through it before we begin. Step 1, angle Y, congruent to angle B. The B in some languages, let me fix that. That is given. I didn't fix it very well, did I? I'll write it one more time. Step 2, YA is congruent to BA. Given. We have this freebie on the vertical angles. We know that angle YAZ is congruent to angle BAC. It's not given, but it's a freebie. Vertical angles are congruent, or vertical angles theorem. And that is angle, side, angle. We can see that we have a pair of angles, a pair of sides, a pair of angles. So these triangles are congruent. By angle, side, angle. And once we have those triangles congruent, then I can make this statement that ZA is congruent to CA, or AC, whatever, using CPCTC. Or you can call it definition of congruent triangles. Don't do both, just write one or the other, all right? And if you are more comfortable using CPCTC, because it's pretty short and it's kind of fun to say, it might not be as fun to write though, so I don't know. Or you can just think of this as, hey, Mr. Hibbett, this sounds like a new concept, and it's not. This is a lesson 1 concept. We're just applying it after we do lessons 2 and 3. Essentially, that's what's happening here, folks. Nothing actually new. We're just taking that extra step after we've shown that the triangles are congruent to list some corresponding congruent parts based on what they ask us to find. Pause the video if you need to pause and think through that before moving on. And then finally, we have this information. Our job is to prove that the angle at A is congruent to the angle at E. Now, here we can do this actually a little bit easier than I'm going to do this, and we'll talk about that after the fact. But if we know that BD is perpendicular to AB, and we know that BD is perpendicular to DE, then that means that these angles are right angles, and it means that those angles are congruent. Yay. We also know that segment BC is congruent to segment CD, that's given information. And then we can apply the vertical angles theorem here to say that those angles around point C are congruent. So this is going to be given. We got to take that a couple steps further to say perpendicular lines make right angles, means that those angles are congruent. This is given. And then this is a freebie right here with those vertical angles. There are other approaches that we can take here, but I'm going to start with this. Prove the triangle's congruent, and then use CPCTC. So step 1. And we've got angle, side, angle here. Pair of angles, pair of sides, pair of angles. I'm going to start with this given information, these 2 statements here, that BD is perpendicular to AB, and BD is perpendicular to DE. This is given, which means that those angles are right angles by the definition of perpendicular. And then we know that all right angles are congruent, as we talked about earlier. Next, pair of sides. They gave us that BC is congruent to CD. I love given information. And then we get the vertical angles around C. All right. Pair of angles, pair of sides, pair of angles. The triangles are congruent. And once I've got those triangles congruent, then I can say that those corresponding parts are congruent. Because corresponding parts of congruent triangles are congruent. Or, definition of congruent triangles. All right, so that covers all of our bases. The faster way to do this one, we could actually do it a couple different ways. We could say these segments are perpendicular, which means that these lines are parallel by the theorem, I think it was 3-6, lines that are perpendicular to the same line are parallel to each other. And then angle A and angle E are congruent by the alternate interior angles theorem. That would save us a lot of work. It would probably cut this down to about 4 steps, I think, instead of 7. Maybe even 3, I'm not sure, we'll kind of see. And the other way to do that would be to do these 3 statements here, that these angles are congruent up to step 3. These angles are congruent using step 5. And then by the third angles theorem, the angles at A and E would be congruent. So we can avoid proving the triangle's congruent. Obviously, the intent here is prove the triangle's congruent and then use CPCTC, kind of fulfilling the work that we've been practicing. All right, so those are kind of the goals for the 4th lesson, to make sure that we can first prove triangles congruent, doing what we've already been practicing at length, and then go one step further to say, hey, now that I know that these triangles are congruent, I can use lesson 1 to say that all these other parts are also congruent to each other. That is lesson 4.